just get started at this and see what we have. Yes, yet another 500 megahertz oscilloscope probe. Now this completes all the probes I need for my Siglent 2000 Plus or X Plus series scope. I got one of these before and I did some tests on it. It turned out to be a really good probe. It's not quite as good as the its namesake from Tektronix, but it is almost as good. I managed to score 2 Tektronix P6139As, and now I've gotten these 2 no-name 6139As, but they're a pretty good probe, and they'll do great for the 350 megahertz situations. I'm still going to use the Tektronix ones for full 500 megahertz. So we'll have a quick look at these. So I've got the probe all decked out in green because it's going to go on channel 4 here. So let's connect it up and see if the scope detects it. And it does. And then we'll connect it up here to the compensation oscillator. And we'll do an auto setup just to get that started there. There we are. Now we're all set up here to do the compensation. Let's see, can we get it stretched out as much as we can so we can get really good view of the waveform. And let's get that looking really nice here. Beautiful, lots of compensation room there. I think that's pretty darn good. Okay. Next, looks like this is partially ripped. Yeah, surface mount resistors. Oh, not much can be said about those. One thing, a pro tip. These will normally come with the resistance marked on the back of the strip here. They've got various different values there. So begin using them at this end. If you begin using them at that end, then you begin to lose track very rapidly of what value they are. And it's a lot easier to read that off the back there than it is to, get out a magnifying glass and try to read the front of them. But yeah, they'll be added to my stash of surface mount resistors. Okay, next, make sure that's whatever in here is out of the way when I start cutting with the knife. The knife is, I think it needs to be replaced. Okay, yeah. So these are right angle through hole PCB mount BNC connectors. These are for a project that I'm working on, and it's sort of going to be like a little calibration unit it's going to have some frequency references in it, some voltage references, and whatever else I can think of to put in it. But these are going to be a part of that. They're fully shielded. They've got very heavy duty cases on them. They should work very well at RF frequencies, but we'll find out when we put them to use. Okay, up next. What do we have here? '74 ACO2s. We got 10 of those. And these are for a project that I'm working on. That's a time domain reflectometer. If you want, I'll show you what that is. and how these work in that circuit. And if you want, I can do a little bit more on the time domain reflectometer, or TDR. They're a handy little device to have for checking the lengths of cables and things like that, to see if you have any kinks or shorts or open circuits in your cables. And yeah, these are for that project. And yeah, also I keep a stock of these around normally as well. But yeah, excellent. More ICs. CMOS 555s. Again, these are for that time domain reflectometer project. These are only for the initial stage I am now, just so I can get a reference frequency out of them. But probably in the end, I'm going to redesign it so that it uses a relaxation oscillator. There are other chips, notably 74 AC14s on there, which are Schmidt trigger inverters, and I can use one of those as a relaxation oscillator and reduce the chip count. So these won't be in the final project, but I do need it right now because the cleaner edge and the faster rise time of the output of the CMOS version of the 555 give me much better performance over what the regular 555 will give me. From Amazon, no less. I'm always buying stuff off of Amazon. Oh, yep. You can never have enough of these. Well, I suppose you can. You actually have too many, I guess. But these are stackable banana plug wires. Nice silicone or very, very, very soft and supple PVC. I'm not sure which, but from the gloss on, there's probably PVC. These are great. These are great. I'm always running out of these, but now I've got another 5 of them. So yeah, you see these all the time in some of my videos. Great stuff. That's our last one. Okay, let's see what's in this one. Something else that's not terribly exciting. These are just BNC cable connectors. So you can connect 2 BNC cables together. They're just stock standard. Actually, these ones were particularly cheap. Looks like they got like a seam on them here. I don't know how that's going to affect them, but for most of the stuff that I do, I'm not dealing with multi-gigahertz radio frequencies or anything like that. So most of the time, I'm well under a gigahertz with any of the work that I'm doing. So I do have a couple of pieces of BNC cable here, and I can show you how this works. It just simply, one cable goes on there and the other cable goes on here. Now they do seem to fit fairly well. They're not too loose. Or I have a better quality one here. How does it fit? Yeah, the better quality one is a little bit tighter, a little bit less wobbly. So anyway, we can check these out. One way to check these out is with the time domain reflectometer, to see if they produce a large enough disruption of the signal that you can pick it up on a inexpensive TDR circuit. But yeah, these weigh practically nothing. Like, they're very thin. This one's much heavier duty. Of course, this one here costs twice what these 10 of them here cost. I didn't need 10 of them, to tell you the truth, but it was $5 for 5 or $5.17 for 10. So yeah, I went and I got 10. Yeah. All right.